Start with our land acknowledgement. So we acknowledge that Indigenous peoples have had and continue to have presence and deep connections with the land on and near the Oak Ridges Moraine, a part of what is known to the Indigenous peoples of this region as Turtle Island. These lands are the meeting place of two treaties, the lands of the Mississaugas of the Credit and those of the Chippewas of Georgina Island, Rama and Beausoleil, and the Mississaugas of Alderville, Curve Lake, Hiawatha, and Scugog Island, which are the First Nations of the Williams Treaties. We would like to thank them and other Indigenous peoples for sharing this land with us. We acknowledge that Indigenous peoples have been subjected to colonial oppression and injustice, which continues to this day. We acknowledge that the first step to reconciliation is recognizing Indigenous peoples and their inherent rights to the land. We will continue to create a better future for our relationships with Indigenous peoples and the land. The Oak Ridges Moraine Land Trust endeavors to honor the land and its treaties by ensuring healthy ecosystems that thrive forever. And we recognize that working together with Indigenous peoples to include ecological traditional knowledge moves us towards an equitable and sustainable future. So what kind of work does the Oak Ridges Moraine Land Trust do? So about 90% of the land on the moraine is privately owned, which makes it vulnerable to development. So we work with landowners to help protect important habitats across the moraine. And the level of protection we offer goes beyond legislation. One thing that's really interesting about the land trusts are that the land that we protect has to be protected in perpetuity. So we can't change our mind in 10 years and decide to put up a condo on one of our protected properties, one of our nature reserves. We're required to hold it in trust and protect it forever. Land trusts are a type of nonprofit that acquires land or interests in land through things like easements to help protect that land. In this case, for the purposes of conservation and protecting biodiversity across this region. So how do we protect the moraine? Well, we contribute to the federal government's goal of protecting 30% of land by 2030. We do a lot of educational programming to connect people with nature, whether it's virtual things like this webinar that we're doing tonight, or whether it's in-person programming. We do a lot of guided walks and activities and things of that nature. We visit schools, we, table at community events. Our protected properties help support climate change resiliency. We protect green corridors between natural areas, and as well as helping protect groundwater resources across the moraine. One of the mechanisms through which we're able to do this is something called the Ecological Gifts Program that the federal government has through the Canada Revenue Agency. And it provides really wonderful tax breaks for people who want to donate their land or put an easement on their land to help protect important habitats there. It's a really wonderful program. And a lot of the funding we receive and the properties we receive through legacy giving as well. So that's another important part of the work that we do. Right now, we have this really exciting project that we're doing in Northumberland County out by Ganaraska Forest. We're restoring this habitat from scratch to try to bring back this lost ecosystem. Prior to the arrival of European colonizers, there was a lot of indigenous land management practices involving fire with things like controlled burns. And there was a lot of species that really depended upon these burns and upon cycles of forest fires for them to exist. This species, the Kirtland's warbler, only breeds around the Great Lakes. Most of them breed in Michigan, but we have breeding records here in Ontario as well. And they depend on two species of pine tree, the jack pine and the red pine. And for jack pine in particular, their cones need forest fires in order to open and for their seeds to germinate. So the suppression of these land management practices, the suppression of forest fires, habitat loss, the conversion of these oak pine forests and jack pine forests into farms and subdivisions really hit this species hard. So although they've had a really spectacular recovery in the US, they're still endangered in Canada. We're trying to create a habitat for them to come here and breed, as well as to support a lot of other species, things like the common nighthawk, the monarch butterfly, the eastern hognose snake. There's a lot of species which are threatened in Ontario and across Canada, which would benefit immensely from bringing back this habitat. So that's something we're involved with right now. We have a lot of really great events coming up as well. I'll put a link in the chat to the events page of our website. Later this week, we have a Valentine's special, animal courtship webinar on Thursday, February 13th. That's going to be really fun. On the 1st of March, we have a guided walk at one of our nature reserves in Schomberg, Ontario, to look for signs of plants and wildlife in the winter. And on March 12th, we have a really exciting webinar with some people who are helping to bring back an endangered butterfly called the mottled dusky wing to Ontario through reintroduction efforts. This is a really recently announced event on Tuesday, April 8th. We have something called the Frog Concert that we're trying for the first time. It's an event at a different nature reserve we have in Schomberg, where we're going to be listening for species like the spring peeper and the wood frog and the western chorus frog at a kettle lake we have at the property at dusk. So that's going to be really fun. And later in April, we have a guided walk to look for spring ephemeral wildflowers, things like hepatica, bloodroot, and trout lily and things like that at that same property. So I'll put a link in the chat in just a minute here if anyone wants to check out any of those events. I'm going to hand it over to Steve in a second, but I'll give a quick introduction. Steve is a semi-retired hydrogeologist with 30 years of experience as an academic researcher and consultant. He's worked on water resources, contamination, and mining projects in Canada, the US, and South America. Steve currently works part-time with the Oak Ridges Moraine Groundwater Program and volunteers with Water Cycles Expeditions, an organization that is connecting people with water through cycling. He writes about water issues around the world in his online newsletter on Substack, The Water Droplet, and he's an active cyclist who spends time hiking and camping. So I'll put a link in the chat as well for that newsletter if anyone wants to check that out as well. But without further ado, I'll hand things over to Steve.
All right, thanks a lot, May, and welcome everybody. I'm going to just flip up my screen here. Um, okay, hopefully everybody can see that, and hopefully everybody can hear me okay. I'm also going to just turn on this little virtual laser pointer here, because I'll be referring to this as well throughout the talk. Anyways, as May said, I'm going to be the title of my talk is Groundwater in the Oak Ridges Moraine, and my name's Steve Shikazi. I don't really need to say too much more about myself. I think thanks, May, for that introduction. But I really want to talk about really to talk about groundwater involves talking about more than just the water that's beneath our feet and that we pump out of the ground in various communities in the area, but really we need to tie that into the other water that we can see, the lakes and the rivers and the rain that falls on the ground and so on. So I'm going to sort of lead us through a story about water um, that really will emphasize the groundwater side. And really I suspect that the people that are here tonight we're here because we're interested in the Oak Ridges Moraine for various different reasons. My interest comes from the water side, but May mentioned a bunch of the other reasons that the Oak Ridges Moraine is important for habitats and green belt and so on. So there's a lot of different reasons that the Oak Ridges Moraine is important, and there's a lot of different interested uh, and engaged groups as well. And the ORM Land Trust is one of them as well. And I'm involved with one called the Oak Ridges Moraine Groundwater Program. And sort of the second part of my talk, we'll discuss some of the things that this program is doing that I'm involved with on a contract part-time basis. So to begin with, here's a brief outline of what I'm going to be talking about today. I'm going to talk about some background information about the Oak Ridges Moraine in terms of what it is uh, as a geologic feature. So I'm going to go into, the study of groundwater involves studying or understanding what the geology is, what's in the ground beneath our feet. And the Oak Ridges Moraine is a geologic feature. So I'm going to talk about that, why it's important and or how it formed. Um, and then I'm going to take a step back from that and talk about the water cycle a little bit. And really, that's really to get into how groundwater is an important component of the water cycle, and then the role of the Oak Ridges Moraine, or ORM, as I'll abbreviate it throughout this talk, will tie into that as well. And then I'll talk about the Oak Ridges Moraine Groundwater Program, or the somewhat awkward acronym ORMGP, a group of really motivated scientists and engineers that I work part-time with. I'll talk about the history of that group and what, how and why it was formed, and then really talking about some of the data and analysis and so on. And I'll wrap up with some final thoughts. So I'm going to be referring to this outline slide a few times throughout the talk, just as a point of reference. And I'm going to start, as I mentioned, by talking about the Oak Ridges Moraine. And May had a figure up very similar to this, some of the same information, but it's 160 kilometers long. It's a geologic deposit of primarily sand, silt, and gravel, and it trends roughly west to east, parallel to the north shoreline of Lake Ontario, from the Niagara Escarpment in the west to around the Trent River in the east. And the other thing so the red outline here is the Oak Ridges Moraine planning boundary. And the other thing I would just want to emphasize here, because I'll be talking a lot about it, is the elevation of the Oak Ridges Moraine. So the greener elevations are higher elevations up to in the Niagara Escarpment here in the west to almost 400 meters above sea level. And you can see that this Oak Ridges Moraine is a ridge of high elevation. And we know that water flows downhill. So this Oak Ridges Moraine plays an important role um, in in water movement on ground surface and in the groundwater underground as well. So I'll be talking about that in a little bit more detail. Why is the Oak Ridges Moraine is important? Again, May talked about a few of these things already. Uh, I think May, you had 250,000 people. My numbers might be a little bit old, but it's a significant population of people that rely on the groundwater from the Oak Ridges Moraine. Um, if you look at this map of sort of the GTA, obviously communities close to the lake get their drinking water from the lake, but as you move further north, further away from the lake, it becomes less um, financially feasible to have a pipeline as you go further north. So communities like uh, Vaughan and Aurora and Newmarket, communities that are growing quite quickly, um, obviously are going to need water as they grow. This graph just shows a time versus population um, plot of Ontario. So that the uppermost line is the population growth of Ontario. You can see the steep growth from the 30s and 40s to the 2000s, and parallel to that and slightly below it is the urban population. So urban, City of Toronto has obviously grown immensely over that period, as well as these communities north of the city, up in Newmarket and Aurora and so on. So the moraine is going to play an important role in that. Well, it does play an important role in that because it provides water to streams and it provides an area to recharge groundwater. And I'm going to really be talking about these key points as we walk through this talk. But just a quick Geology 101 lesson. The Oak Ridges Moraine was formed in the last periods of glaciation, which were just over 10,000, probably 12 or 13,000 years ago. And these glaciers that were on a continental scale. When we think of glaciers today, or at least when I do, I often think of the glaciers that we see when we go to the Rocky Mountains in Alberta and BC, these glaciers that exist between mountain valleys. But the last ice age and previous ice ages before that, but these were continental scale lobes of ice. It's been estimated by geologists that this area of Ontario was the ice thickness above this area of Ontario was 1,000 meters or a kilometer of ice, which is really hard to imagine that much ice over this area. But the lobes, they advanced and retreated over thousands of years. So there's a repeated motion of advancement and retreat. And every time these glaciers move, they're scouring the rock and the sediments beneath it, and they're pushing lots of dirt around over thousands of years. So the last period of glaciation, some 12, 13,000 years ago, there were lobes coming out of the north, named after some of these water bodies, Georgian Bay and Simcoe from the north, but there was also this Ontario lobe over Lake Ontario that came out of the east and pushed north against the other lobes. So this next picture here shows sort of a block diagram of that exact sort of a cartoon representation of what's been interpreted to happen. So we've got the north on the left. So that's up that Simcoe lobe coming from the north and pushing in. And then from the south, there's the elevation of the present day Lake Ontario, but that Ontario lobe was pushing from the east and then to the north. And as those lobes came in, they were pushing sediments around, and then they retreated and left this ridge of sediments that we now call the Oak Ridges Moraine. This is a three-dimensional diagram that I also had up on the title slide, but you can see the elevation highs are sort of the darker colors, the browns and so on. You can see that this ridge here, the spine of the Niagara Escarpment here in the west on the left. North is sort of to the upper left where there's the southern edge of Georgian Bay. You can see Lake Simcoe here. That's at a quite a bit of higher elevation than Lake Ontario, but this ridge separates Lake Simcoe and Georgian Bay from Toronto and Lake Ontario. And you can really see this ridge from the escarpment all the way out to the Trent River way out here. And in the distance out here, you can see the that's up Haliburton Highlands and Algonquin Highlands and so on, up in the Canadian Shield. So I want to dig into uh, no pun intended, I want to dig into the geology a little bit. And I'm showing this map again, and this red line represents a cutout or a cross section that I want to show some of the geologic interpretations that have been done by many geologic experts over decades now. But again, we've got the north on the left. So here's Lake Simcoe at an elevation of around 219 meters above sea level. We've got Lake Ontario here that's at around 75 meters above sea level. And then as you drive, if you think about driving down Highway 400 or 11 or something like that, you drive uphill, and it's not this steep. This is exaggerated, but you drive uphill to the crest of the moraine, and that peaks out at around 360 meters above sea level, and then drops down as you drive it towards Toronto and then to Lake Ontario. So the ground beneath our feet there, and I'll talk about this in a little bit more detail, but the ground beneath our feet is a complex of different geologic deposits from those advances and retreats of the glaciers over tens of thousands of years. And that plays an important role in how the Oak Ridges Moraine interacts with the water cycle. This is what we might see beneath our feet, and this is from Nick Isles, is a professor of McMaster, a geologist, and he's just one of dozens of geologists from academia and the Geological Survey of Canada and the OGS, the Ontario Geological Survey, and consultants and different levels of government that have studied the Oak Ridges Moraine and the geology in this area for decades. But you can see I won't get into all the names and everything, but the numbers here on the right is the approximate or estimated time before present. So the sediments that are on top, that are right beneath our feet as we walk the moraine, have been deposited most recently, some 12,000 or 13,000 years ago. And as you go deeper, you get older sediments as well, until you eventually get down to some rock material. The rock is exposed at the Niagara Escarpment, but around the Oak Ridges Moraine, you can go through several hundred meters of these loose sediments, sands and gravels and clays until you hit a rock unit. So you can see the early glacial periods were on the order of 100,000 years ago. So I'm going to so that's the quick sort of geology 101. I want to tie that now into the water cycle. And when and I've done this, but if you were to Google the water cycle and look up images, you'd probably get dozens, even hundreds of images, something like this. And it's something that I think is taught in grade school now, the water cycle, which really just describes how water in its various forms moves in this circular pattern through our environment. And because it's a cycle, there's no real start or finish. But for the purposes of this talk, I want to start with precipitation. And precipitation here in Ontario is mostly rain, but as you know, it can be snow or sleet or any of the other nasty things that can fall in winter around here. But for the sake of this talk, let's just think about it as water in its liquid form, rain hitting the ground. So when water hits the ground, it can do one of several different things. And the first thing that it will do will be flow downhill. So that can be down the slopes of the Rocky Mountains or down the slopes of the Oak Ridges Moraine just by gravity. In a city, it'll flow, from higher elevation to lower elevation down a street or down a parking lot until it gets to a sewer and so on. But in the non-paved world, it'll flow down a slope, eventually reach a stream or a wetland or a lake. If it gets into a stream, we in the water world will call that stream flow. So that's sort of the first component of rainfall and what happens to it. The other component is some of the water is going to get into the ground, and we refer to that as infiltration. I'll use the term recharge, which is a term that we hydrogeologists prefer. But when that water gets into the ground, it can also flow, and groundwater flow tends to be a lot slower than streams. You can sit on the bank of the river and just watch it flow by, and if something's floating, it'll be gone in a few seconds. And because that water is moving, tens of meters in a second. In groundwater, a fast groundwater flow rate might be, 10 meters in a day. Uh, so there's a different scale here at work, but groundwater that flows through the ground uh, will likely eventually at some point flow back to the surface, and that can come out into what we call a seepage face, or it can come into springs or lakes, or it can flow into the rivers or even into the oceans. So that's something that I'll introduce shortly, but it's something that we refer to as discharge. So we have recharge coming in and discharge coming out. Once it's in the water bodies and back on surface, we get that evaporation component. Transpiration, plant roots can also take water out of the ground, but then we get evaporation, condensation in the clouds, and then the cycle repeating. So that's sort of 2 minutes of the water cycle. When we think of that first component, so when I said precipitation and then runoff typically goes into streams. So I want to show this diagram again. And again, just for reference, that red outline is the planning boundary of the Oak Ridges Moraine. And then I've got these blue arrows that show the direction of runoff or surface water stream flow. The main streams are shown as those little blue veins throughout the area. But as I mentioned, in this area, the topographic high is represented by the Oak Ridges Moraine and the Niagara Escarpment out here on the sort of north-south trending Niagara Escarpment out here in the west. But as we've stated, the Oak Ridge Moraine is a topographic high, so water is going to flow from that topographic high into Lake Ontario. And there's a whole bunch of streams. I'm sure many of you live in these areas or have heard of these streams before, but the headwaters for all of these streams is in the Oak Ridges Moraine. Similarly to the north, you've got the Nottawasaga River, and you've got water flowing again off that ridge of the moraine towards Lake Simcoe. Some of it's flowing towards the Trent River and so on. So really you can see just in this huge area, the importance of the Oak Ridges Moraine. And I'm just talking about surface water at this point, the stream networks and so on. Here's what it looks like if I take a step back and you can really see again the Moraine Nottawasaga River in this area discharging into Georgian Bay at Wasaga Beach. You've got some smaller rivers like the Holland and the Black that flow into Lake Simcoe, which drains north in Aurelia and then flows into the Severn River that also drains into Georgian Bay. And the Trent River is really quite interesting because you've got flow from the south off the moraine to the river system, but you also have flow from the north, these sort of Haliburton Algonquin highlands to the south that's also feeding the Trent River system and all the many locks and so on. The Trent River sort of does some zigzagging and it flows out into Lake Ontario, kind of scoots around the east edge of the moraine down in the Trenton area. So I'm gonna take the next step now and talk about the groundwater side, and if you think about how water flows, how much water that gets into the ground, or that recharge component that I've talked about, is really going to depend on what kind of dirt is beneath our feet. So obviously, if you think about really coarse gravel, an inch or thereabout size of gravel chunks, if you pour water on it, it's going to move through that gravel very quickly. If you move to finer materials like a fine sand, you're still going to get some water through there, but it's going to move slower. Uh, a loam or silt is a mix of fine grain and coarse grain. You're going to get some water through that as well. And then you can imagine a fourth category here, like a clay, almost like a potter's clay, right? It's really dense. It can hold a lot of water, but water doesn't flow through clays very readily at all. So I'll talk about that, the importance of the different types of materials as it relates to the Oak Ridges Moraine. But again, I just want to again emphasize a couple of points with relation to the water cycle and the groundwater components. So I've found this little sort of layer to recharge water that gets into the ground. So it's the component of precipitation that gets in, and that's going to happen in certain areas. So here, up here, this you can imagine this is sort of the Oak Ridges Moraine. It's a higher elevation, and the sediments are the type of sediments that allow water to get into the ground. So these are referred to as recharge areas, and the Oak Ridges Moraine is a key recharge area. And the other point I want to make is the water that comes back out of the ground, and that's referred to as discharge. And water can discharge into creeks like here. There's a couple of examples of creeks. There's some other water body over here where groundwater is discharging, and it can discharge just into low-lying flat areas as well, and wetlands and so on. So that's important to remember. And then the other thing I just want to emphasize on this figure is the time scale. So from a recharge area to a discharge area, you can have a whole range of flow times. So it can be on the scale of weeks or months if it's recharging and discharging close by. But some of the flow lines, some of that recharge water can get very deep, follows its path and comes out. A couple other terms that I want to introduce with respect to groundwater. In this diagram, we're looking at a cutout of what might be a typical setting of the world beneath our feet. So we've got ground surface up here at the top with the grass, and below our feet in this particular area is a sand. So think about it as a beach sand, like like the many beaches we have along the Great Lakes. So when we think about sand, as a kid, I used to sit on the beach on Lake Huron and dig a hole, and the hole you could really dig a nice hole until you hit water, and then it would start collapsing, right? So when you hit water, then you hit that's where the water table is on the beach, and then it's hard to keep digging in that kind of sand further, but you can drill boreholes and you can get into this water and so on. So that sandy unit that's holding water is referred to an aquifer. It's a geologic unit that can hold, like I showed earlier, that allow a lot of water to flow through. And there's types of hard rock too, fractured rocks and porous rock that can be good aquifers as well. A couple of good examples are the communities of Guelph and Cambridge. Their municipal pumping wells are in fractured rock, or many of their wells are in fractured rock. So as you move further down in this particular example, you keep going through this sand aquifer. In this case, now we hit a clay. In this particular scenario, now that clay acts as a barrier, so water isn't going to flow through that clay very readily. This clay will likely still be really saturated, but it's not going to allow water to flow. So geologic units that don't allow water to flow are referred to as aquitards. So we have aquifers and aquitards based on the type of geology that it's in, that is beneath our feet. And the Oak Ridges Moraine is a really complex that is at different depths beneath our feet. This lower unit here is a gravel aquifer that's confined by this clay layer. And that can be good in many ways, because if you start having chemical spills or road salt up here, it might get in and contaminate this shallow aquifer. But the deeper aquifer, at least in this area, has a layer of protection, because water is not going to get through this unit as readily. but then you have to pay attention to the fact that this deeper aquifer is getting its recharge from some distance farther away, uphill somewhere. And it could be someplace like the Oak Ridges Moraine, and this could be the town of Newmarket or something like that. So there's a lot of things to think about when we look at groundwater and we study it as hydrogeologists. So what does the water cycle mean in terms of the Oak Ridges Moraine? This is from an Oak Ridges Moraine website. Again, it's a layer cake. So we have uh, south here, sort of Lake Ontario down here. To the north would be towards Lake Simcoe. And here's that ridge of the Oak Ridges Moraine sediments. The Oak Ridges Moraine sediments are, like I mentioned, mainly sands and gravels and clays. So they're good aquifers. They're good aquifers, which means water can flow through it. And they're good aquifers, which means they're close to the ground surface. So that means they can take in a lot of recharge. So the Oak Ridges Moraine is an important recharge area. That water gets into the ground, flows through the more Oak Ridges sediments and can come out into seepage and feed rivers in this area. Rainfall can fall and feed rivers there. Some of this Oak Ridges water gets a lot deeper into deeper aquifers. In the north here, there's pumping wells in some of these deeper units as well. So there's really a lot of water resource reasons for or benefits of the Oak Ridges Moraine. I'm going to show this diagram again, just with a little bit more, now that we're armed with a little bit more knowledge about the water cycle and the Oak Ridges Moraine. If we rain on the moraine, well, it's going to rain everywhere, but the rainwater on the moraine is going to get in here because it's coarser sediments, and then it's going to follow these hypothetical darker blue arrows here. It's going to flow through the moraine, and then again, that's a good shallow aquifer. There's some of these lower sediments, these units down here, they can be aquifers as well. These little units here, I won't talk about them too much, but those are channel deposits, and they have to do with how the glaciers advanced and retreated. And when these ice sheets are moving, there's a lot of water that's melting. As the water melts, you have a lot of channels or rivers underneath the ice that are moving sediments on their own. And those result in these tunnel channels. And they can result in being filled with coarser sediments, and they can be aquifers as well. So again, these hypothetical groundwater wells might be in the tunnel channels. They might be in the shallow Oak Ridges sediments, and they might be in some of these other units as well. But a lot of that, the bulk of that water, though, is coming from this topographic high of the Oak Ridges Moraine. So I'm going to talk now in the second half of this talk, now that we sort of understand groundwater and the role of the Oak Ridges Moraine. I want to talk about this ORMGP, or the Oak Ridges Moraine Groundwater Program. And I'm going to start just by giving a little bit of history, but the program started in 2001, primarily by my colleague, Steve Hollish. Steve and his partner, Rick Gerber, are the co-managers. And then there's Mike Mason and Britt, who are full-time staff. I'm a part-time contractor, and I believe there are 3 other part-time contractors, and we're doing various different tasks for this group. But it's funded by 5 different municipal governments, the municipalities of Durham, York, Peel, and Halton, and the city of Toronto. And then there are 10 conservation authorities that are partners as well because of their geographic affiliation, I guess, with the Oak Ridges Moraine. And I'll just show that on a map. Here's the map again: York, Durham, Toronto, Halton, and Peel, and the conservation authorities that are associated as well. But just a brief history lesson about the formation of the ORMGP. In the late 90s, there was a lot of discussions. There was a lot of increasing awareness about the importance of groundwater resources through the Toronto Region Conservation Authority, municipalities of York and Peel. And there's similar discussions between the region of Durham and the Central Lake Ontario Conservation Authority, which is down around in the Oshawa area. So these discussions were happening because there was an increased awareness of the importance of groundwater. From the Conservation Authority side, there was a group called the Conservation Authorities Moraine Coalition. And together with those municipalities, they started to talk about they wanted to address concerns with regards to protecting the Oak Ridges Moraine, particularly with the protection of water resources. So this goes back to over 25 years. By 2001, all these conversations, there was enough overlap that they decided to sort of merge these initiatives and form the really awkward acronymed YPDT CAMC. So York, Peel, Durham, Toronto, and then the Conservation Authorities Moraine Coalition. So that's what Steve Hollish really spearheaded back in the early 2000s. Um, by 2017, they rebranded as the ORMGP, so it's a slightly smaller mouthful. And then in 2017, the region of Halton joined as well. So the main objective of the ORMGP is really to work with partners that I showed a couple of slides ago to understand and manage water resources. And in order to do that, I've outlined a few tasks here on this bullet list. And fundamental to this objective is to develop and maintain a database of geology and hydrogeology data. And I've worked in the consulting industry for many years until I semi-retired a few years ago. And when we start a new project, a big part of that project is just trying to get all the data. There's been researchers and government and consultants who have studied just about every inch of Ontario, of Southern Ontario, but it's really hard to pull all these different pieces together, particularly back in the old days when everything was, on somebody's hard drive or in a paper report. So part of that first bullet there is really to have a centralized database for all our partners so that they can come to one kind of a one-stop shop for all of that data and information. In addition to that, it's we maintain a web-based data and mapping portal, and I'll show some screenshots of that, and I'll give the link so that people can go there. But there's a public um, data portal and there's a private one as well. Some of the partners have some sensitive information that they want to protect. But the public one is a lot of the data and a lot of the information and interpretation is available on the public site. We also provide technical support to partners. Some of our partners have hydrogeologists on staff, and they're doing a lot of the work. Some of the smaller conservation authorities don't have that kind of expertise, so we support that. We support everybody, and then we've developed a lot because the database is so big and comprehensive. We've developed a lot of tools that provide analysis and really dig into that data, and that leads to really making decisions that are data driven or science based. And when we think about what kind of decisions might be made, decision making here at the top of the pinnacle might be if we put in a new condo, or if we turn farmland into a neighborhood and pave over much of it, how are we affecting that stream that's a half a mile away? Or how are we affecting the water levels? Is that pumping well that's a mile away going to be affected? So if we think about what kind of decisions we typically make that require water, and they all do, we start with this foundational pyramid where the database and data management is the foundation of that. And if we start there and we think we want a way to store all the data, and we want to make it accessible, and we want to do some quality assurance, quality control on it, and we want to make it usable. So that's the foundation of it. As we move up, once we do that, we can get into some interpretive tools, come up with a geologic framework, and I've shown some cross sections on that. Then we can talk about the groundwater component or hydrogeology component. And then there's modeling and so on. But all of these tools sort of build up in complexity in order to make data-driven, scientific-based decisions. So we get our data from a bunch of different sources, groundwater data from different levels of government, the Geological Survey of Canada, Environment Canada, the MOE and the MNR, or I guess the MECP is the provincial government now. But we get borehole data, water levels, geologic records, chemistry under the groundwater heading. We get surface water data from different levels of government, and that includes stream flow and flow rates. Climate data is primarily from Environment Canada, publicly available from their websites, but we get some data from our municipal partners as well, and that includes air temperature and precipitation data. So the database itself has grown, and these numbers are over a year old now, so I apologize, but it still gives an idea of the magnitude of the data. But it's over 100 gigabytes in size, and that includes over 500,000 borehole records. And at this scale, this map is showing a little red dot for every location. But the borehole records themselves, they include geologic records. Each borehole, well, not each, but many of the boreholes include a geologic record of what they drilled through. But many of the boreholes too include at least one water level measurement that was taken at the time of drilling. Many of these boreholes also have instrumentation where they've put in automatic data loggers where they can take a water level reading every hour or every day, and then that information can be downloaded. So there's over 140 million water level records within those 500,000, excuse me, boreholes. There's over 100, or sorry, over 1,000 climate stations, mostly from Environment Canada, and they're all taking precipitation and air temperature readings at different times, daily or hourly or yearly, and so that's over 30 million precipitation and air temperature readings. 17,000 surface water monitoring stations. So these are places within a river that are measuring the flow. So within a given river, you might have 100 different, well, maybe not 100, but a dozen different um, stream flow monitoring locations, and you can take a simple measurement at one time, or you can also put in these data loggers and measure stream flow daily for many years. So that's over 5 million stream flow records. And then one of the I think unique features of this is that we've hired students over the years to scan in old reports, academic research reports, consulting reports, government reports, and so on. And then we assign a location to where that project was done. So users can come in, and as I said, sort of a one-stop shop. If you want to do a project in Richmond Hill, for example, you would zoom in on the map here and say, give me all the data and tell me what reports have been done in this area. So this database is sort of it's an organic being. It's always growing. Our partners are always giving us new data, and so on. And we've got one of the full-time employees, Mike Dowdy, is really staying on top of all the data that's coming in and making sure it gets into the database. So that database foundation was sort of the primary part of the project, and I think it's really important to talk about data when we talk about groundwater. But the next step above that was looking at geology and geologic interpretations. And really, when you think about what's going on beneath our feet, we'll typically drill a borehole, and we'll drill through some sand and some clay and some till, and eventually we may hit a hard rock unit, a bedrock unit. It might be Canadian Shield or like granite, or it might be like the escarpment, like a limestone type of material. But that whole layer cake that's above the bedrock in itself is very complex, because I could drill here and see a certain sand and clay and gravel sequence, and I could drill a hole a mile away and it would be a very different picture. So it's really taking all of that borehole data, that geologic data, and coming up with a story and understanding the glacial history, and then interpreting between all of our borehole data. And like I said, many geologists have been doing this for many years. And this cross section goes from the southern tip of Lake Simcoe right through Toronto to Lake Ontario. So it's a little bit east of Yonge Street, I think. But you can imagine again, starting at Lake Simcoe here on the left, driving up some hills and then driving back down. It's a little bumpy. It's not bumpy, but there's a little bit of undulating topography until you reach Lake Ontario. These different colored units here are the interpreted geologic surfaces. So the unit that we refer to as the Oak Ridges Moraine is this orange unit. Another key unit is this bright green unit here, and that's our Newmarket Till, and that's a pretty extensive regional aquitard. So remember we talked about Oak Ridges Moraine being an aquifer, then there's an aquitard unit, and then beneath that that Newmarket Till, there's other aquifer units and aquitards as well. And then at the bottom of this layer cake is the bedrock unit. So there's channels that are in the bedrock, and there's channels that are in these unconsolidated sediments as well. This shows a lay at The north is up here in the upper right, so that would be where Lake Simcoe might be. Some of these are hard to see, but you've got Aurora here, Newmarket in this area. So those of you that live sort of north of the city um, might recognize some of these names, but the topographic unit or the top of this layer cake is the ground surface, and the purpley red colors are the higher elevations of the Oak Ridges Moraine. And you can see that it's not just a straight line. There's places where it juts to the north and then cuts back to the south, and then around Ballantrae there's some thick Oak Ridges Moraine sediment again. But as you go deeper into this layer cake from the ground surface icing, you get into the Oak Ridges Moraine, which is the orange unit. Some of these channels that I talked about are filled um, with material that makes for good aquifers. So Aurora and Newmarket are in this Young Street aquifer, which is in a channel. And then there's other channels as well. But mapping out these channels and understanding the deposition based on glaciers is really important to understanding the groundwater resources. This figure is from the Geological Survey of Canada, and they've done a lot of work on the Oak Ridges Moraine. I don't really want to get too much into it, but again, you can see the time periods here from the last deposition was about 13,000 years ago to the first period of glaciation or interpreted period of glaciation some 135,000 years ago, which scoured bedrock and started to deposit these different units. But when we think about this layer cake, um, and we start on top. So the top is the ground surface. And this is what the ground surface looks like. I've shown a couple of pictures very similar to this, but the higher elevations of the Niagara Escarpment are here in sort of the white and reds out here in the west. And then the other high elevations are up here, the highlands of the Algonquin Park area, and then the Oak Ridges Moraine here, which is this fiery red unit that we're talking about. So that's the top unit. That's the elevation of the ground surface. But what's the bottom of the layer cake in this case? The bedrock surface. And there's been a lot of work done on studying that bedrock surface. This is what the bedrock surface looks like. And the first thing you notice is, well, the Niagara Escarpment is bedrock. So that hasn't changed a whole lot. I'll just flip back. You can see it's still there. The highlands, the Canadian Shield up here in the northeast, that's still mostly there as well. I'll just flip back again. You can still see that outline, at least of higher elevations. But the higher elevation of the Oak Ridges Moraine has disappeared when we look at bedrock, because the Oak Ridges Moraine isn't bedrock, it's the different layers of the cake. Oops, sorry. The other thing to note is that there's this what's been called the Laurentian Channel, which is a bedrock channel where what is now Georgian Bay drained into current day Lake Ontario. And when you look at the ground surface, you can't really see that too well because it's been infilled with sediments. So we now have the top and the bottom of that layer cake. What I want to show in this figure is the thickness of that layer cake. So out here in the area of the Niagara Escarpment, the thickness, it's actually very thin, right? There's places where the Niagara Escarpment is exposed, so the thickness of our layer cake or the thickness of sediments is zero. Similarly up here, there's places up in the highlands up here where the Canadian Shield is at surface, so the thickness is zero. But along the moraine and through that Laurentian Channel, you get very thick sediments. I want to say 400 meters is upwards of 400 meters thickness in these areas. And that's important to know from a groundwater perspective, because when you have thick sediments like that, there's potential for groundwater resources. And then that ties in with some of the communities that are relying on groundwater. One of the some of the tools, I'm going to talk about some of the interpretive tools that our team has worked on. One of them is looking at precipitation. And when we think about precipitation, we think about it in terms of the water cycle. So what my colleague Mason has done, Mason's a brilliant water resources engineer, and he's come up with ways of creating a precipitation map. So we can see precipitation, here's the scale down here. It's dark is around 1,000. This is millimeters per year of precipitation. Probably the average in this area is around 800 to 900 millimeters per year, and the range is 700 to 1,000. So highest up here in the north, and then sort of in the GTA, we're probably around 700 or 800. But that's important to understand from sort of a regional picture or a regional water cycle or water budget, we refer to it as. Mason's also got numeric computational tools to look at the runoff component. So the runoff is higher with the darker colors. Runoff is higher up here in the shield where there's not much sediment for it to get into the ground. And runoff is high in the city of Toronto, where it's mostly paved with parking lots and buildings and roads. The other main component is recharge. So recharge in the cities tends to be low because of these same asphalt barriers. But in the Oak Ridges Moraine, recharge is higher because more water's getting in because of the types of sediments that are at ground surface in it, and a lot of it hasn't been paved yet, thankfully. So the website, this is a screenshot of the website. I don't think I'm going to have time to really give a live demo, but if you go to oakridgeswater.ca and look under maps, it'll take you to this website here, to something like this. And really it's based on a commercial software called ArcGIS. Like I mentioned, there's partner and public sites. All of the spatial data that I've talked about, the 100 gigabytes of data is available on the maps, and as well as these interpreted surfaces. So all those layer cake surfaces that I've shown are available on there as well. And the layer cake here is the ground surface, and then I'm showing um, I think I'm not sure what the dots are in this case, but you can show any types of you can show all the borehole data or all the climate data and so on. And then there's some data analysis tools that I want to just talk about briefly in the last bit of this talk. One of the really interesting things that Mason has built is the ability to look at historic data. And in this case, this data is from one of the Environment Canada weather stations right in the city of Toronto. And this particular station started taking precipitation and air temperature data back in the mid 1800s, right up until the early 2000s. And it's right in the city of Toronto. So we can look at the average air temperature uh, every year for about 100 for over 150 years. We can talk about climate change, and we can talk about urban growth and so on, but really this is showing an increase in trend. So the zero line on this graph, we call these graphs some anomaly graphs. So what we do is we look at all the data for the entire time period and we take an average, and that average is plotted as zero. And then we look at the individual data. So from 1840s or whenever these first data was, how does that individual data compare to that average? So back in the 1800s and into the early 1900s, we were below average. But as the 1900s started and the Industrial Revolution and the city was growing like mad, temperature went up. So we can look at this and we can say, hey, climate change, look, climate change is real. But that's a little bit dangerous because there's a lot of other things going on, right? Perhaps this weather station in the 1800s was surrounded by grass and trees and farmers' fields. As parking lots went up around and buildings went up around, that's going to affect the air temperature, right? How the solar radiation reflects off the pavement is going to increase a temperature reading in the same location. So there's a lot of things going on here. This is part of the story, but we just need to be careful about what the story is because there's a lot of other factors. This is another data analysis tool. Again, it's looking at a time period from early 2019 to late 2021. So a 2.5, 3 year period. And what we're looking at this time is this jagged blue line that's trending up and down represents the pumping rate at a well in Ballantrae. So pumping well 3 in Ballantrae. So you can see there's certain pumping rate here of maybe 500 cubic meters per day. That's how we typically measure volumetric flow, 500 meters per day. And as we get into the summer months when water demand is higher for watering lawns and washing cars and so on, that pumping rate goes up to 1,000-ish and then drops back down into the fall when our water demand is typically lower before rising again the next summer. The line on the top now represents the water level in that Ballantrae well, and it's really it makes sense that as we pump higher, as we get higher pumping rates, the water level drops because we're pumping harder, and then we see that same trend each year for this short period. The other thing is you see a couple of, I think these points here are could be errors. But you can see there's a correlation here with a couple of spikes in pumping and a sharp drop in the water level. Sometimes they jack up the pumping rate in a given well if they have to turn off an adjacent well. So there's a lot of sort of interference between wells that's going on, or they'll shut off a well to clean it up and turn up the pumping well on, turn up this pumping well and so on. But you can see sharp declines. But plots like this really allow us to look at the state of our groundwater resources. In this case, when we when we uh, when we pump less, the water level is recovering. If we were to see a sort of continuing downtrend, like for example in the Midwestern United States, they're pumping their aquifers dry there because they're not getting enough recharge. As long as there's water there, they're pumping it, but now they're finding this water level in some of their wells just keeps dropping and dropping and dropping, and that's really an important it's important to understand these things when cities are growing and so on, and water demand increases due to population growth. The third and final data analysis tool I want to show has to do with surface water or stream flow. Uh, this is the Rouge River in Markham. The bottom lines here represent stream flow within the Rouge River at a specific point in the Rouge River from the 1990s to present day. And you can see stream flows, there's spikes in stream flow. And knowing what we know about the water cycle now, we can say, well, these spikes in stream flow are probably because of rainfall events. Heavy rain means that water is going to flow off the ground and into streams. The other thing is it's going to be snow melt, right? When you get a big flash of warm weather, a lot of snow is going to melt and run off into the streams as well. So the graph that's coming down now is just think of it as rainfall again. We refer to it as atmospheric yield because snow isn't treated the same as rain, because a foot of snow doesn't mean it's the same as a foot of rain, obviously. So there's ways of calculating what the equivalent amount of rain is from a foot of snow, for example, and it's going to depend on the air temperature because the snow's not going to melt right away. It's going to wait till it warms up, hopefully soon. But you can see these precipitation events and how they might correspond to stream flow, right? There's different things that are forcing these peaks in stream flow, and groundwater can be included, but sometimes you'll see a huge precipitation event that corresponds with a stream flow event. So really understanding that can be important for predicting floods and really understanding how water is moving through our system. And this bottom graph just shows it's a discharge map versus the return period or frequency. With a lot of flooding events that we've been having lately in the city of Toronto, and there's been some, all over the world, really, they come up with these maps. And if you listen to the news, sometimes they'll talk about, oh, a 100-year flood or a 50-year flood. They're doing things like this kind of graph. And if you look at this graph up here, this dark blue line here, and the flow rate of 40 cubic meters per second, looks like there's one event here, maybe one here and one here. So over this 30-year period, there's maybe 3 events that are 40 cubic meters per second or higher. So that plots around here. Here's 40, and it's about once every 10 years. So higher flow rates occur less frequently, and lower flow rates occur more frequently, which makes sense. But this kind of graph is used in flood prediction, saying, okay, well, what's my 100-year flood look like? And here, they don't have enough data, but it would probably be up in the sort of 70 to 80 cubic meters. These kind of graphs are really important and useful, but it's important to understand too that with the way the climate is changing, the frequency of extreme events, high rainfall events, and so on is changing. So what was a 100-year flood 10 years ago might not be a 100-year flood today. So these graphs are always being redrawn. So just some final thoughts to wrap up. I talked about the Oak Ridges Moraine, where it came from, glaciation and so on. I talked about the water cycle, in particular, the importance of groundwater. This graphic here I pulled from the from a Toronto Star article, might have been a decade ago now, but it really, I find it really interesting because it covers a lot of the information in one graphic that I talked about today, from the formation of from the glaciers to where the water moves and so on. So that's a neat summary. I also talked about the importance of the Oak Ridges Moraine as it relates to groundwater recharge and the headwaters of streams. I talked about the importance of data and all the work, really trying to bring together all the important work that's been done over many decades, and bringing it, and the Oak Ridges Moraine Groundwater Program, pulling it all together in data storage and having mapping and analysis tools for that. And these last things just summarize it, and really, again, with that sort of objective of making decisions that are data driven. So that concludes my talk. There's a couple of email addresses here, my personal email, but also the email that I have with the updated our website, and it went live last month. So that's there now. If you want to go to the mapping features, you can just go up here to the open access, and then you'll be able to play around with some of those things. If you want to do that, you can contact me. My newsletter, my water newsletter is here, and if you want to take your phone out and scan that, or just visit the water droplet, uh, you can as well. And I'm also on LinkedIn, and this here is found at oakridgeswater.ca. So hopefully, I know I went through a lot of material here, but I'm not sure how we are for time, but I can hang around for some questions.
Yeah, thank you so much, Steve. That was really excellent. I know I learned a lot, and I was yeah, it's amazing how much material you're able to pack in that amount of time, and yeah, just how much information you're able to get across. That was really wonderful.
Yeah, it's my pleasure. Thanks.
We have if anyone has any questions, please feel free to throw them in the chat here. We have someone named Bruce Wilson here is saying that they're a retired hydrogeologist of 34 years, and they found this presentation to be very well presented. They really liked the talk. And then we have a geophysicist named Don McMaster who agrees and says it was a great presentation. So um, we have some people who appreciated it.
Oh, great. Great. Yeah, thanks for that feedback.
Maybe we'll just hang around for a second here and give people a chance to throw any questions they may have. Bruce Wilson says, "How many people watched this?" It looks like we had about 20 people on the call tonight, but we're recording it, so we're gonna put it onto our YouTube channel like we do with most of our webinars, and then you'll be able to share it and watch it again if you like. And I'll send out an email tomorrow sharing that.
Yeah, I've got the comments up too.
Mhm.
So yeah, thanks everybody for the feedback.
All right. Well, if we don't have any more questions, I might call it an evening. But it seems like everybody really enjoyed themselves, and yeah, I'd like to. Oh, one question here. Um, Do developers have to do testing before doing development? Someone says.
Oh, that's a good question. And uh historically, yes, they have to do an environmental assessment that includes water. Um Nowadays, the current provincial government, that's right now on hold because of the election. But in the last 7 years of the current PC government, they've been doing a lot of dismantling of environmental regulations. For example, I was at a workshop today I live in Waterloo, actually, Kitchener-Waterloo, and I was at a workshop here in town in Waterloo, a groundwater workshop with over a couple hundred people. And I was talking to some of my former colleagues who work at various conservation authorities, and they were saying that they're no longer allowed to review development applications, which is really puzzling to me because that's the whole reason conservation authorities came about. Um, they can only review development applications if they're strictly if they're within a wellhead protection area, which is even more important. But still, there's other very environmentally sensitive areas that are not necessarily within what wellhead protection area, and that's all a result of a lot of the let's say looser regulations that the current provincial government has brought in.
We have one other question here from someone named Bob Bowles asking, he says he noted that you include the Oro Moraine map. You can see the recharge and discharge areas for the Oro Moraine, asking if it would be possible to get a copy of that map.
Uh, yeah, Bob, why don't you reach out to me on the email I think it's still on the screen.
Hmm.
Why don't you reach out to me at my Gmail and I can get you connected with that. I'm actually involved in a project up in Barrie right now with the city of Barrie. So, recharge, discharge, so whatever you specifically want, I might be able to track down. I know that there's been a lot of work on groundwater done up in that area.
Perfect.
Thanks, Deborah. My pleasure.
All right. Well, it doesn't look
Thanks,
like
Mark.
we
Yeah.
have any more questions. And I think we're sort of coming to the end of our time here, but I just wanted to thank you one more time, Steve, for presenting here this evening. And like I mentioned earlier, if anyone wants to check out this presentation again, I'll be sending out a link to a recording of it sometime tomorrow. Um, but yeah, thank you for that. As I said, I learned a lot. I've been working at the Land Trust for over a year now, and I'm always impressed at the new information I can learn about this region with some of these webinars and presenters that we bring in. So this was really excellent.
Yeah, thanks for organizing and inviting me, May. It was my pleasure.
Wonderful. Well, I'm sure I'll see some of you at the next one, and everybody enjoy your evening.